In this video, we're going to talk about limiting reactants and percent yield. So let's look at an example here where we have hydrogen and oxygen reacting to form water. So we need 2 molecules of hydrogen and 1 molecule of oxygen to form 2 molecules of water. So if we look at our example here, in the first box, we have hydrogen molecules in white here. And there are 6 of those. So we have 6H2. And then we have our oxygen molecules in red. And we have 6 of those as well. Then if we look at the product side of this box, we have 6 water molecules here. And then we have 3 leftover oxygen molecules floating around. So which one ran out first? Well, it looks like we ran out of hydrogen, and then we got 3 oxygen molecules left over. So since we ran out of hydrogen first, that's the one that limited how much water we can make. So let's look at a formal definition of limiting reactants. The limiting reactant is the substance that is completely consumed in a chemical reaction. That's the one that we run out of first, and therefore we don't have any more of that left to make any more of our product. So the limiting reactant is the one that determines how much product we can make in our reaction. Let's look at a practical example here. Let's say that you have 16 slices of bread and you have 10 cheese slices, and you want to make cheese sandwiches from this. Now, if you're going to make a sandwich, that means you need 2 slices of bread. So if I've got 16 slices of bread, and I want to put 2 slices of bread on each sandwich, that means I can only make 8 sandwiches from that. So even though I've got 10 cheese slices, I'm going to run out of bread unless I'm going to make some of these sandwiches with only 1 piece of bread. If I'm going to do a normal sandwich with 2 slices of bread on it, then I can only make 8 sandwiches. And then I would just have 2 cheese slices left over. Now let's think about this from the point of view of a chemical reaction. We're given a chemical reaction here where sulfur trioxide reacts with water to form sulfuric acid. And we want to know what the limiting reactant is when 20 grams of sulfuric acid reacts with 10 grams of water. So we need both sulfur trioxide and water to make sulfuric acid. So if we run out of one of those, we can no longer make any sulfuric acid. So we can calculate from each one of these how much sulfuric acid can be made from that amount using stoichiometry, and then we can see which one would run out first. So let's start with the sulfur trioxide. We have 20 grams of sulfur trioxide. And if you calculate the molar mass of sulfur trioxide, that comes out to 80.07 grams of sulfur trioxide. And according to our reaction, 1 mole of sulfur trioxide reacts, and we form 1 mole of sulfuric acid. Now I'm just gonna calculate how many moles this makes, because we don't really care how many grams it could make if it's not the limiting reactant. So I'm going to stop here at moles of sulfuric acid. If we divide 20 by 80.07, we come out with 0.249 moles of sulfuric acid. Now we're not done yet, because we also have to see how many moles of sulfuric acid we can make with 10 grams of water. So if you calculate the molar mass of water, it comes to 18.02 grams. Of water per 1 mole of water. And then according to our reaction, 1 mole of water forms 1 mole of sulfuric acid. So if we divide 10 by 18.02, that comes out to 0.555 moles of sulfuric acid. Now, one thing that students will do sometimes is they will try to add these together to determine how much sulfuric acid or how much product you can make. But you can't add them together, because this is just like a recipe. Just like with our cheese sandwiches, we need the bread and the cheese to make a sandwich. When we're doing a chemical reaction, we need all of the reactants to make the product. If we run out of one of the reactants, we can no longer make any product. So all we're doing is calculating for each one of these how much sulfuric acid we can make, assuming we have enough of the other reactants. So if we look at these two and compare these two, with sulfur trioxide, we can make 0.249 moles, assuming we have some water to react with it. With the water, we can make 0.555 moles of sulfuric acid, assuming we have some sulfur trioxide to react with. So which one are we going to run out of first? Well, we're going to run out of the one that makes the least product. So this, the sulfur trioxide, is going to be our limiting reactant. If we just have water by itself, that's not going to form any sulfuric acid. I promise you, your water that's sitting there in your water bottle is not going to randomly turn into sulfuric acid. It just doesn't happen. If we just have sulfuric acid by itself, it's not going to randomly turn into sulfuric acid. So once we run out of the sulfur trioxide, we can't make any more sulfuric acid. So if we have 0.249 moles of sulfuric acid, typically we're going to want to know what the mass is that we can make. So 1 mole of sulfuric acid has a molar mass of 98 So if we multiply 0.249 times 98.09, we come out with 24.50 grams of sulfuric acid. So that is the mass of sulfuric acid that we can make. Let's take one more example here. 10 grams of methane is burned in 20 grams of oxygen to produce carbon dioxide and water. And we want to know which one is the limiting reactant and how many grams of water will be produced. Now this time we're not given the reaction, but we can write it because we're pretty much told here what the reaction is. CH4 reacts with O2 to form CO2 and H2O. And then we need to balance this. So I've got 4 hydrogens on my reactant side. I need to get 4 on my product side. And then once I do that, I have 2 plus 2 is 4 oxygens on my product side. And only 2 on my reactant side. So I need to balance that. And then I only have 1 carbon on each side. So that's already balanced. So we want to figure out between the methane and the oxygen, which one is our limiting reactant. If we start with 10 grams of methane, we have 16.05 grams of methane per 1 mole of methane. And then 1 mole of methane. Now this time I have 2 products. So I could pick either one of these to figure out which one is the limiting reactant. But I'm going to go with water because the second part of this question asks me how many grams of water will be produced. So if I do the calculation here for carbon dioxide, I'm just going to make more work for myself because I'm going to have to go back and redo the calculation with water. So 1 mole of methane forms 2 moles of water. So if I put into the calculator 10 times 2 and divide that by 16.05, I can make 1.25 moles of water. Now I have 20 grams of O2 and water has a molar mass, oxygen has a molar mass of 32 grams per 1 mole. And then 1 mole of oxygen, actually 2 moles of oxygen react and form 2 moles of water. So if I take 20 times 2 and divide that by 32 times 2, that comes out 2.0625 moles of water that it can form. So in this case, oxygen is my limiting reactant because that forms fewer moles of water. And then I want to know how many grams of water I can make. So I take my 0.625 moles of water and I multiply that by the molar mass of water, which is 18.02 grams per mole. And if you multiply 0.625 times 18.02, that comes out to 11.3 grams of water that I can make. So now let's talk about percent yield. When we do our reaction, we don't always get as much as we think we would. There's a lot of reasons that we actually make less than the amount we would think that we would be able to. Sometimes we lose some of our reactants. Sometimes the reaction doesn't go to completion. Sometimes there are side reactions happening that we don't know about. But often our percent yield, our amount that we actually make, is much less than how much we think we can make. The amount we think we can make is the theoretical yield. The theoretical yield is the maximum amount of product possible in a chemical reaction, given the quantities of reactants that we have. So this we determine using stoichiometry. Okay, so if you're given a quantity of reactant, you can use stoichiometry and calculate how much you think you should be able to get, which is your theoretical yield. Your actual yield is the measured amount of product that you form. So our percent yield then is our actual yield divided by our theoretical yield multiplied by 100 to make it a percent. Let's look at an example here. Aluminum burns in bromine liquid, producing aluminum bromide. In one experiment, 6 grams of aluminum reacted with an excess of bromine to yield 50.3 grams of aluminum bromide. We want to calculate the theoretical and the percent yield. So we start with 6 grams of aluminum, and we actually made 50.3 grams. So this is our actual yield here. We have to calculate our theoretical yield. So if we start with 6 grams of aluminum, if you look at the periodic table, the molar mass of aluminum is 26.98 grams of aluminum per 1 mole of aluminum. And according to our reaction, 2 moles of aluminum forms 2 moles of aluminum bromide. And then 1 mole of aluminum bromide. If you calculate the molar mass of aluminum bromide, it comes out to 266.68 grams of aluminum bromide. So 6 times 2 times 266.68, and then we divide that by 26.98 times 2. That comes out to 59 grams of aluminum bromide. So this is our theoretical yield. To figure out our percent yield, we take our actual yield and divide it by our theoretical yield. So our actual yield is given to us in the problem as 50.3 grams. And we calculated that we should be able to make 59 grams. So if we take 50.3 divided by 59 and multiply by 100 to make this a percent, we get a 65% yield. Okay, so this wraps up theoretical yield and percent yield and limiting reactants. So we will get some more practice with this in class.